and share and subscribe and like.
In this video, we will discuss an important method of solving wave equations, and this method is given by D'Alembert's, and therefore it is known as D'Alembert's method of solving an wave equation. Here we put two new variables, u equal to x plus ct and v equal to x minus ct. Then del u by del x is equal to del u by del x is equal to 1 and del u by del t equal to c. Del v by del x equal to 1 and del v by del t equal to minus c. So this is the substitution we are now taking in this equation. So let us first convert this variable y into u and v. Del y by del x equal to del y by del but x u is a function of x and t, so we have del y by del u into del u by del x plus del y by del v into del v by del x. We are transferring this y in terms of new variables u and v, but del u by del x and del v by del x is equal to 1, so this will be converted into del y by del u into 1 plus del y by del v into 1 equal to del y by del u plus del y by del v. Okay, so that means we have del by del x is equal to del by del u plus del by del v. Then del 2y by del x square equal to, that means del by del x of del y by del x equal to del by del x is what? Del by del u plus del by del v of del y by del x, that is del y by del u plus del y by del v. This is equal to this will be del 2y by del u square plus del 2y by del u into del v plus del 2y by del v into del u plus del 2y by del v square. But in the second order derivative, del u by del v equal to del v by del x. So this term will be del 2y by del u square plus twice del 2y by del u into del v plus del 2y by del v square. Okay. Now del y by del t equal to del y by del t equal to again del y divided by del u into del u divided by del t plus del y divided by del v into del v divided by del t. Del u by del t is a c, so this is a u c into del y by del u plus del v by del t is a minus c into del y divided by del v equal to c into del y divided by del u minus del y divided by del v. Okay, so del divided by del t, this is c into del divided by del u minus del divided by del v. Then del 2y divided by del t square equal to del by del t of del y by del t equal to c into del divided by del u minus del divided by del v into del y into c into del divided by del u minus c into del y divided by del v. C into c square into del 2 y divided by del u square minus del 2 y divided by del u del v minus del 2y divided by del v into del u minus minus plus del 2y divided by del v square. So this is the term. Then or del 2y divided by del t square equal to c square into del 2y divided by del u square minus twice del 2y divided by del u del v plus del 2y divided by del v square. This is, so let us put these values in the given wave equation. If we put these two values in the given equation, del 2y by del t square is a c square into del 2y divided by del u square minus twice del 2y divided by del u into del v plus del 2y divided by del v square equal to c square into del 2y by del x square. Del 2y by del x square is del 2y divided by del u square plus twice del 2y divided by del u del v plus del 2y divided by del v square. Okay, so this is the given equation will be now converted. Then look at the common terms that will be cancelled. Here c square will be cancelled. Again del u del 2u by del u square, this is a positive sign, this will be cancelled, and this one, this is also cancelled. What remains, this is minus and this is a plus. Okay, so this will be, this is equal to, we get from this 4 times del 2, 4 times del 2 y divided by del u into del v equal to 0, or del 2 y divided by del u into del v equal to 0. Now integrate this, integrating with respective to v. So when we integrate with respective to v, we have del y divided by del u equal to function of u, since when we integrate it may be function of u. Now again integrating with respect to u, we have y is equal to integration of f of u into du plus sub psi of function of v, or this is an again function of u. So let us take an another function, that is phi of u plus psi of v, and u means x plus ct plus psi of x minus ct, and this solution is called as a D'Alembert's solution. Now let us find these values of phi and psi. To do this, we put y is equal to 0 when y is equal to f of x when t equal to 0, and del y by del t equal to 0 when t equal to 0. So let us differentiate this first. We have del y divided by del t equal to phi dash of x plus ct into c minus psi dash of x plus ct x minus ct into minus c. Okay, now at t equal to 0, this value equal to 0, c into phi dash of x minus minus plus minus minus plus psi dash of x, c into psi dash of x. Okay, so we have phi dash, this is value of plus, okay, plus, and this will be minus, right, plus this minus c, then you can see that this CC is not 0, so phi dash of x equal to psi dash of x. Phi dash of x equal to psi dash of x. Integration gives us phi of x equal to psi of x plus integrating constant b. Now apply the first condition y of y equal to 0 when t equal to 0. Y equal to f of x, y equal to f of x when y equal to f of x when t equal to 0. So this is equal to phi of x plus psi of x. Phi of f of x equal to phi of x is psi of x plus b plus phi of x, so equal to twice psi of x equal to f of x minus b, and psi of x equal to 1 by 2 f of x minus 1 by 2 b. Okay, therefore psi of x, phi of x equal to psi of x plus b, psi of x 1 by 2 f of x minus 1 by 2 b plus b, and this is equal to 1 by 2 f of x plus 1 by 2 into b. So this values is phi of x and psi of x. Then you can see that the solution is converted into, therefore y equal to, what is my y? Here you can see y is equal to, y is equal to y equal to phi of x plus ct, that means 1 by 2 f of x plus ct plus 1 by 2 b plus psi of x minus ct 1 by 2 f of x minus ct and minus 1 by 2 b plus 1 by 2 b minus 1 by 2 b will be cancelled, and we have 1 by 2 into f of x plus ct plus 1 by plus f of x minus ct. This is the solution of the wave equation by D'Alembert's method.
Hello guys, thank you for watching video.